Welcome. This is Module 3 of Science in Today's World, and this short instructional video is for discussion activity 1 on energy sources and uses, and the activity is the Personal Energy Calculator. Now, the Personal Energy Calculator was originally developed by Dr. Walter Ernst of MIT about 10 years ago, and the version that we will use is the Excel workbook that you have available to you. The Excel workbook has 3 pages. This is an image of the first page, the summary page. Second page, page 2, is a set of rules for how to calculate conversion factors for household energy use. And page 3 is a set of rules for how to calculate energy use for transportation or mobility. The first thing we will do is to compute the conversion factors that will be entered in this column of the summary sheet. Next, you will go back and enter your personal consumption factors in the first column, and automatically the energy use per year will be calculated and totaled down here under the grand total. And the carbon dioxide emissions that are vented to the atmosphere are calculated from the total energy use. Let's go through one example of how to calculate a conversion factor for household energy use, and then we'll give you a chance to calculate the remaining conversion factors. Under household use, we calculate energy use for heat, air conditioning, electricity, and indirect energy for the total area used of your house. Let's say that the climate we're in is cold, that we heat the house using oil, that the oil burner is new, that is, the efficiency is very high, and the insulation in the house is good. For that row, the conversion factor is 12, and you'll enter that in the green box. Now, you should determine the conversion factor for your house, and you can follow the rules for the remaining sections of this page of this workbook now. Okay, now that we are back, you'll see that I calculated the rest of the conversion factors. Let's say that if the climate is cold, we're still heating with oil, the efficiency is high, the oil burner is new, the insulation is good. For air conditioning, the conversion factor is 0.9. For electricity, under the same conditions, it's 2.2 if we use incandescent light bulbs. And that if the construction is wood and the house is relatively new, that the conversion factor is 5.9. If you go to the summary sheet, you'll see at the top that these 4 conversion factors have been automatically entered. Now let's go to the mobility or transportation spreadsheet, the third spreadsheet. If you do mostly suburban driving, the conversion factor for miles driven per year is 1.92. If you use public transportation, let's say a train, and the train is always full, then the conversion factor is 0.8. At this point, we'll take a short break and allow you to enter the other 2 conversion factors. Okay, now that we're back, you'll see that if we take a bus, let's say, and it's moderately full, the conversion factor is 0.8. And when we take an airplane, the airplane is always full and the conversion factor is 500. Again, if you go to the summary sheet, you'll see that these numbers were automatically entered under the mobility section. Now that we're finished entering the conversion factors, we'll go back and enter the consumption factors. And remember that these numbers only have to be estimates. You don't need to know the exact area of your house, nor the exact mileage that you use, or the amount of gasoline that you use. They are estimates, but also that they are for individuals. So you don't give the whole area of your house, but rather you give the portion that you will use. You might divide that up by the number of people in your house. So let's say, for example, that our residence is 2,000 square feet. There are 2 of us in a house, and the area of heated is the whole house. But that would be 1,000 square feet that is heated, air conditioned, that we have wired for electricity, and the indirect energy, that is the part of the house that is used energy but we don't necessarily always use all the time, is also total used area is 1,000 square foot. So you see the consumption is multiplied by the conversion factors. The demand, or the total energy use, is in the 3rd column, and that's added to give 21,000 kilowatt hours per year. We'll take a short break at this point, and you can enter the rest of the usage factors. Okay, welcome back. You'll see for this sample spreadsheet that we've entered the transportation or mobility consumption numbers. So we use about 500 gallons of gas. We drive 10,000 miles per year. Our car weighs about 2,000 pounds. And the rest of the transportation numbers under nutrition, you have 3 choices. If you eat a non-vegetarian diet, you'll enter a higher number, and if vegetarian and then a vegan diet, you use much less energy. So this is an example of indirect energy, where the energy goes into preparing the food, not the direct energy that you use in consuming your meals. We enter 10,600 for a, let's say, vegetarian diet. Here's your office at work, the cost of your furniture and appliances at home, and the amount of clothes you buy per year, and your internet use. So the first set of numbers are the consumption numbers. There's public consumption that's added to it, so it's the amount of energy that we use in the country that may go into our street lights and other forms, from fire department and our police department and other public safety forms. And so this is a portion that's attributed to us, and this is a fixed number. A grand total is 105,374 kilowatt hours, which is slightly above average. And the CO2 emission is 51,000 pounds of carbon dioxide that is vented to the atmosphere, that contributes to our greenhouse gas emission and influences global warming. And that's how we use the personal energy calculator. And now you'll return to the instructions for the activity, and you will discuss your results on a discussion board.